Welcome to Biota Live. I'm Tom Barbalet, and today I have the pleasure of talking with Bob Mottram. Hello, Bob.
Hello, Tom.
So, as this is your first time on Biota Live, although you've been mentioned on quite a few previous Biota Lives, would you like to give an introduction to the listening audience and perhaps some background in your interests in artificial life and robotics?
Right. Well, my name's Bob Mottram, and I'm a software engineer by profession. I've been interested in artificial intelligence mainly, but also peripherally artificial life for a very long time, I think. My interest in AI goes back to teenagehood, really. When I was a kid and my first computer, or second computer, I was about 10 or 11 years old. It came with a book which contained computer programs, which is extremely rare these days, I suppose. There were just listings of programs. One of those programs was called The Clever Computer, and it was basically a version of the ELIZA program written by Joseph Weizenbaum. And I remember having tremendous fun and typing that program in and thinking about the possibilities of what if you had more questions and more answers and a bigger memory and this sort of thing. So I've always been interested in computers and the possibilities of computers and what you can do with them. And my career has pretty much followed that. So I've always tried to stay within the software realm and do as much computer programming and computer-related stuff as possible.
And in terms of your interest in robotics, when did that start?
It probably grew out of just an interest in computers in general. As I said, I was interested in AI from quite a young age. I'd read an article in a BBC Micro magazine called, I think it was Acorn User, about AI in about 1985, which was quite interesting, although it didn't have anything to do with robotics. I was peripherally aware of robotics in the media and stuff like that, Star Wars and stuff like that, although I was never a big sci-fi fan. Probably the first real robotics that I actually did would be making little beam robots out of junk, inspired by a guy called Mark Tilden. He had an article in Scientific American in the early 1990s. I don't remember exactly which year, but I remember reading that and being quite inspired by it, that you could actually make things which moved around and which were almost autonomous, solar powered, and you could put on a window ledge and just have them roll around and do their own thing. And you could make them really cheaply out of old Sony Walkmans and other kind of electronic junk. Shortly after I got onto the internet and started milling around on the World Wide Web, there was a web page made by a guy whose name I'm not even going to attempt to pronounce, but he runs the Solarbotics website, solarbotics.com. And that would have been in around 1995, 96. And I ordered some components off his site and made my first beam robots. I made quite a few of those in the end, out of all kinds of junk. I think I only have one now that survives, more or less functional and intact on the window ledge. A lot of the others went by the wayside, degraded, or their gearboxes made out of plastic sort of got corroded by sunlight, or that sort of thing. So that was my first sort of endeavour in robotics, beam robotics. And it's definitely something that I would recommend to anyone who is sort of interested in robotics and wants to try it out, because you can do it at very low cost. It gets you involved with using a soldering iron, maybe, just getting your hands dirty, and you can do it really cheaply. So kids can do it as well. So it's definitely a good entry point. It's not the highest intelligence you can get in robotics, but it's a nice little place to start.
And in terms of your introduction to the artificial life community, did that come through Steve Grand?
I don't think so, no. I was interested in A-Life long before I was even aware of Steve Grand. There was a book that I read in the early 90s. I forget what its title was, but it was all about artificial life.
Was it the Stephen Levy book?
Might have been Stephen Levy, yeah. Might have been, yeah. And there was another one I think it was called Out of Control, which was a bit later, mid-90s. I don't remember who wrote it, though, which also includes some A-Life type stuff. Yeah, I remember reading about that. That was pretty interesting, and it fitted well with the kind of stuff I'd read previously about artificial intelligence. It seemed to fit the mould, and it's a bit more expansive than artificial intelligence in that it covers the whole gambit of survival in an environment, which is more interesting, I think, more holistic. And it kind of gelled with what I'd been reading by the philosopher John Searle about, or it might have been Daniel Dennett possibly, about looking at the system as a whole, looking at the whole iguana rather than just some narrow components of it. I was on a course at the time learning C and COBOL. COBOL was pretty horrible, but I quite liked programming in C. And one of the tasks was just like a free-for-all task where you could write your own program. And one of the programs I wrote was an A-Life type program, which was like a two-dimensional environment. It was made up of bytes. Each byte represented a creature of one kind or another. And they could move around in a primitive sort of way and sort of compass directions and sort of collide with each other and maybe eat each other. And I think the people who were teaching me were utterly unimpressed by this artificial life program that I'd written, because it had absolutely no utilitarian purpose whatever. But it was quite amusing to me anyway, and it was one of my first ventures into that sort of area. The other program which I remember, which was very influential on me, was one developed from a book written by a guy called Randall Beer called Intelligence as Adaptive Behaviour. That was a simulation of an artificial cockroach, which consisted of simulated neurons. And I thought that when I saw that in action, I thought that was completely fascinating. I was utterly captivated by it, and remained so for quite a number of years afterwards, actually. For the first time, I could see how it might be feasible to create a sort of artificial organism out of simulated neurons and have it run around and eat things and sort of run along walls or avoid obstacles. So I would say that was a big influence on my thinking at an early stage anyway, with regard to artificial life and possibly robotics as well. There were some robots built in the 1990s, I think, which were based on that sort of idea. I think the sort of hard equivalents of that simulation, which I think was originally written in Lisp in around 1990, something like that.
Was that the Rodney Brooks stuff at MIT? I seem to remember robotic cockroaches there, but yeah,
yeah. Although I don't think it was actually based on that. All that sort of stuff was in the air in the early 90s. It was in the popular science magazines, the MIT Mobot Lab, stuff like that. So all those kinds of things were influencing my thinking at that time. And I was a sort of higher education dropout, really. I briefly went to a technical college in Middlesbrough, but didn't fare very well there at all, and dropped out pretty quickly. because I was always interested in sort of AI and that sort of thing, and they weren't even remotely interested there. In fact, they had some contempt for people who were interested in that sort of subject. So I didn't get along very well there. So I was basically in my early 20s, late teens, early 20s, I was just reading as much as possible about AI, robotics, that sort of stuff. Almost as a subject for being in a mobile lab myself. In the early 90s, I was mainly either unemployed or doing very menial kinds of work. My first real software job was in around 1994-ish. Most of the jobs I had up until 1998 were completely unrelated to robotics. They were basic IT, so things like databases, accounting software, things of that nature. Sort of getting my foot in the door of the software industry and getting some real practical experience at the sharp end. And it was really only in 1998 that I even had any contact with robotics in a sort of commercial or official sort of capacity. I had done some stuff with robotics prior to 98, as I say, with Beam Robotics. And also I bought a mobile robot at great expense. It was about £2,000, which was a lot of money for me at the time, from the US. It's called a PC Rover. Quite a large blue robot with a 486 PC motherboard inside, and some electronics to control the motors, and some ultrasonics on it. So I did some initial experiments on that, and that was quite interesting and quite useful to get some experience of how robots actually are programmed and the fundamental difficulties in getting robots to work. In 1996, I think it was, or 95, I bought a Kinectis QuickCam, which was the first webcam, and tried using it with this PC Rover robot, and had very, very limited success. But I did present a poster at a meeting at, I think it was Edinburgh University, related to that, where I was trying to combine the sonar on the robot with some very, very elementary vision to get a better idea of distances, ranges around the robot, so it could have some sort of spatial awareness. By the late 90s, I was doing some moderately sophisticated robot stuff, although in a purely hobby capacity, in my spare time, outside of developing databases and accountancy packages and that sort of thing.
Can you talk a little bit about certainly the hobbyist artificial life community is quite distinct from the academic artificial life community, and in kind of, I guess, describing the notion of a hobbyist within artificial life, a lot of that comes from the hobbyist robotics community as well. Can you describe the distinction in the hobbyist versus the academic robotics community? And you say that you were still presenting posters at academic conferences, even though that you were a hobbyist. Can you describe that liaison at all?
Yeah, in that particular situation, that was one meeting that I went to at Edinburgh. I don't remember the title of the meeting, but it was something related to artificial intelligence and robotics. And they were asking for people to do posters or write papers for it. So I was completely outside of the academic community, and I just noticed that this notice appeared somewhere on Usenet, probably on one of the robotics, maybe comp.ai or comp.ai.robotics, something like that. And I just noticed the most important thing for me was that it was free to show up. You didn't have to pay any subscription fee or anything like that, or conference fee. So I thought I would try and enter it anyway, and maybe meet some people who had similar interests. So I showed up, and various people gave various speeches on various things, and some of them were some of them were moderately interesting, but not really in the areas that I was particularly interested in at the time, which was mainly just the very simple stuff of learning what is in the environment and responding to that in some way. A lot of the academic robotics going on at that time seemed to be mimicking either the Rod Brooks stuff from the MIT Mobot Lab, or doing very, very elementary simulation stuff related to typically things like using backpropagation neural networks to avoid obstacles in a simulated environment. Very simple obstacle avoidance with simulated sensors on a simulated robot. And it was certainly interesting to meet people in the academic community, and they certainly had quite a different sort of outlook on things than I had anyway. They were very much, although I had met people from academia before, mostly in relation to my father's work on botany, and just him having academic people around while I was growing up. Mainly they were sort of quite difficult to talk to, quite guarded in their responses to questions. But I suppose you'd expect this from academics. I mean, now that I know a bit more about that sort of side of things, probably these things shouldn't have been a surprise in hindsight.
It is interesting because you are describing the perfect dichotomy. Do you want to talk about your father's work?
I don't really know a huge amount about my father's work, really. He's in the was in the horticultural business, and I think he's now the editor of the British Cactus and Succulents Society Journal. So I grew up in an environment which was surrounded by plants, particularly cacti and succulents, in northern England, which is in itself is pretty unusual given the climate. And he was selling plants and books mainly to hobbyists, but also to academics and collectors. So I suppose you could say that I'm quite familiar with being in an environment with other hobbyists and hobbyists' sorts of passion for their subjects, that sort of thing. Although I never really took a massive interest in what my father was doing, and I don't have any great knowledge of cacti myself, although people sometimes assume that I do.
But in terms of your knowledge of biology and your relative readings and these kind of things, it's interesting because the description of hobbyist and the way that it's often used in I don't want to say derogatory sense, but in a way which is not is the exact opposite of what you're actually describing. That what you're describing is a lifetime passion that is not necessarily embodied in academia. But
just from experiences with my father and the people he knew, I would say that there tends to be a bit of a clash between the academic community and the hobby community. Hobbyists often seem to believe that academics are not that smart, that they don't know their fields very well, that they're often just doing it for the money, and that they're given positions beyond their expertise. And I don't know very much about it from the academic side, but that's often the hobbyist sort of viewpoint.
I can hear the torches being lit. I think you're you're describing the dichotomies perhaps particularly too sensitively for the artificial life community as well. So beautifully put, Bob. So moving on from this, late 90s, you're developing databases in your day job, and you're working on robotic vision as your hobby. How did it continue from there?
So in 1998, I got my first real job in you could say, the robotics industry. And that was in the glass container industry. And this was a complete contrast to previous jobs that I'd had, which had been a lot more oriented towards retail. Whereas this was much more industrial, dealing with hostile environments, and really pushing the computing to the limit, really, both in terms of computing power and in terms of the kinds of environments that computers can exist in without failing. So the machines that I was working on were things which are used in manufacture of glass articles like bottles, containers, of various kinds, anything ranging from sort of massive Magnum champagne bottles you see at Formula One events, down to really, really tiny perfume containers or olive oil containers, things like this. And they're sort of handling these sorts of glassware as they're literally as they're being made from molten glass. So there's a lot of safety aspects to consider. Everything has to be really, really accurately timed and sequenced within the range of a few milliseconds, so that everything happens in the right order, and you don't get things falling over or crashing into other things. So the glass industry was a really nice industry to get into, and it taught me an awful lot in all kinds of ways, both about industrial robotics and about the process of inventing things from scratch, and the kinds of expertise that need to come together to be able to build a commercial system. In that sort of robotics, there's very little in regards to actual AI. Most of it is classical control theory, being able to sequence things and control them accurately, avoid oscillations, being able to diagnose things using oscilloscopes, sometimes even like stroboscopes, things like that, to make sure that things are running at the right speed. So it's pretty fascinating industry to work in. Although it's also quite, as I mentioned before, it's quite a hostile industry when you're actually installing things. The areas that I was installing in are what's known as the hot end of the glass container production. The temperatures are very high. There are annealing layers involved which are gradually cooling down the hot containers, so the atom will fall into a nice lattice structure to give them maximum toughness. So it's hot, it's extremely noisy. You need ear protectors to protect your hearing, and there's also a lot of high frequency vibration. In the early days, we had embedded PCs in some of the industrial robots that were handling these glass articles, and it seems laughable now, but they were running Windows 95, and they also had hard disks, and the hard disks lasted for all of maybe a few months at most before they tended to destroy themselves. And I would frequently get returns where you could take the hard disk out of the PC and just to rattle it in your hand, you could literally hear the broken pieces of the platters just rattling around. So hard disks lasted for very short periods of time, but fortunately in the late 90s flash disks were beginning to emerge, and I managed to get some operating systems installed onto flash disks, which was a challenge in itself at that time because they were very small by today's standards. But I think we were probably early adopters of flash disks for use as a hard disk substitute, just out of pure necessity, really. So as I say, pretty interesting industry to work in. Lots of stuff going on, constant innovation from year to year. And although theoretically each machine that was shipped was usually supposed to be identical, in practice there were nearly always customer requirements, which meant that machines had little tweaks here and there to make them suitable for a given type of factory. And that involved international travel as well, travelling mostly to different places in Europe. I even, under one condition, I even got to travel business class on one particularly urgent job when they needed somebody really, really fast. One thing about that industry is, as with most industrial manufacturing, is that production is king, and anything which halts production, even for minutes or hours, is a major problem, where you're potentially losing large amounts of money per hour. So the cost of flying somebody to a location is probably quite small compared to the amount of money that you can potentially lose in production. So a completely different world from the world of hobby robotics, certainly. And as I say, pretty interesting stuff. While I was working there, I was also continuing with my interests in AI, and I started to build a humanoid robot, eventually called Rodney. And that was really just to help me experiment with AI algorithms and vision algorithms particularly. The kinds of things that I wasn't getting to do it on the industrial side, on the commercial side.
And so you built Rodney, and in terms of the experiences from that, was there any vening into the stuff that you'd looked at previously relating to artificial life, or was it just I don't even know the methodology associated with building humanoid robots? Or what kind of components went into it, and what did you learn from the experience?
I should probably describe a bit of the history of the Rodney robot. It goes back to about year 2000. At that time I was living in the centre of York, and if anybody knows York, it's a 2,000-year-old city in the north of England, originally founded as a fort by the Romans and eventually taken over by the Vikings, I believe, called Jorvik by the Vikings. Anyway, I was living in York, and around 2000 I was kind of wandering around York looking at all this fancy architecture and wondering whether there was any computational way that I could maybe build models of all these tremendous buildings with their Gothic architecture. And I looked around on the web at the time and found one website, which I think was the University of Cambridge, where they had some sort of demo program, which was intended to reverse engineer the structure of buildings from camera images, mainly by tracing lines over the image, manually indicating key points on the image and then manually matching them to other images. Basically manually solving what's called the multi-view stereo problem. And I tried using that and had very, very almost no success with it whatever. It came out with really disastrous results, so I thought there must be some better way than this to handle this kind of problem. And it would be really nice. My fundamental motivation at that time was that it would be nice if future generations could kind of look back on York and see the changes in buildings and see the three-dimensional structure of buildings at that point in history. If we had that sort of data for, say, hundreds of years ago or thousands of years ago, it would be really interesting to see the evolution of the city over the previous 2,000 years. So at that time, that was my main sort of thinking and reason for getting into that sort of thing. But as I say, I'd had really no success with some of the demo programs that I'd seen on academic sites. So I was kind of searching around the web for stuff related to obtaining 3D information from camera images. Probably one of the first things that I found was a 1996 paper by a guy named Hans Moravec, where he'd managed to get some 3D information from stereo cams. I think that was at CMU University in the United States, and the results there looked pretty good. They looked like something which would be of interest, and that maybe you might even be able to use to reverse engineer the structure of buildings. And so I kind of wandered around York and thought of a name for this project, which I originally thought of as calling it the Sentience Project. I don't really particularly remember why I called it that. It just something that happened to pop into my head at the time, and which, doing a search on the web at the time, showed that nobody else was using that title for a project. So I had some initial goes at taking photographs of buildings and from different locations, and then computationally trying to write a program at the time in Visual Basic to match these images together and try to compute distances. I think that program might even still be somewhere in the backwaters of my website on the old version of it. So once again, just like the demo program from, I think it was Cambridge, I had very, very little success in doing this. But intuitively, it seemed like a problem that ought to be solvable. It's really just triangulation. If you know the positions of the cameras and the orientations of the cameras, and you know matching points, then you should be able to triangulate those points in space, projecting out the rays from the cameras or projecting in the rays from the point back to the camera imager, and then calculate its distance and then figure out the geometry of the scene. But it turns out I was quite naive in the early stages, and that this is quite a hard problem, and it turns out to be a problem that a lot of academic research has been expended on over the last 2 or 3 decades. So after a while of wandering around York taking photos, no doubt in a highly suspicious manner, I decided that in the rain and snow and so on, and at around that time there was also flooding as well, I decided that it might be a good idea to try to make this problem a bit more containable by making it into something that I could do back at my flat without having to wander around in the cold with a camera. So I thought of using a couple of webcams as a substitute, and then just using those webcams situated on a desktop to look at objects on the desktop and try to figure out their 3-dimensional structure. So you can see on my website, if you look at some of the early Rodney stuff, it's basically just a aluminium frame with a servo panning 2 quick cams. I think they're quick cam express cameras, in a fairly crude sort of way. Initially, I think I only had a pan axis, which just panned the cameras around, but eventually I also added a tilt, which tilted them up and down. And that's really how the Rodney robot started. I named it Rodney because partly after Rodney Brooks, and partly after a well-known sitcom character from a sitcom called Only Fools and Horses. Knowing how limited artificial intelligence is and how stupid even the best algorithms are, I thought that was kind of appropriate sort of name. So that was the fundamental origin of Rodney as a platform to try and experiment with spatial awareness and sensing space using cameras, trying to calculate 3-dimensional models and things of that nature.
And then this vision experiment moved into a humanoid robot.
Yeah, the humanoid aspect of it was really inspired by, probably inspired mostly by a robot at MIT called COG, which was developed primarily by Rodney Brooks, although also worked on by many other people. When I'd initially got onto the internet in around 1994, one of my main motivations for getting onto the internet was to get access to papers on artificial intelligence. And at around about that time, they started. The MIT AI lab happened to be one of the early academic sites to become available and to even make papers available online. What at the time was a really horrendous format called PostScript. It required you to use something called GoScript to view it. at the time I was using Windows 3.1, and the version of GhostScript on Windows 3.1 was just horrible. It was so bug infested, it was unbelievable, and the lengths that I went to download various papers from MIT on the cod robot was quite extraordinary, really, by today's standards, certainly. Many hours of fruitless downloading and partial downloading and joining files together and lines dropping and stuff like this. So I've been interested in that sort of stuff and read a lot of the papers related to development of cod. So I thought, since I've got these, so fast forwarding to 2001-ish, I thought I've got these cameras and they're stuck on top of the platform, so I might as well have a go at something which might be similar to a cod robot. It'd be a lot smaller, be far lower budget, but fundamentally the kinds of things that the cod robot was doing and the problems that it was tackling seemed like the kinds of things that I could tackle on a desktop using pretty low cost rudimentary hardware. There were some very sophisticated things done with the cod robot in terms of developing novel types of actuators. I think they were called series elastic actuators, which had compliance to them. But to my way of thinking, developing these novel actuators didn't seem like something which was absolutely fundamental to being able to have some sort of intelligence or some sort of adaptivity and be able to recognize things in your environment and maybe even just in simple terms point to things rather than actually manipulating them. So that was my initial motivation for turning a couple of cameras on a stand into something which looks a bit more like a humanoid. And even today, the Rodney robot is mostly a couple of cameras on a stand. The actual body and arms and so on rarely come into play. For most of the last decade, I've been really primarily just working on the very, very elementary task of having a robot be able to perceive its environment, be able to see what's in the environment, be able to see the shape of the environment. Because to my way of thinking, if you can't see those very simple things, if you can't see the shape of what's around you, then your intelligence is extremely limited. Rodney went through quite a number of revisions, and in the early days I tried to do it in the same sort of way that I would approach a problem in a commercial environment, and I actually did do some drawings. I drew things out and measured things, did it the proper way. But I soon found out that, of course, my nice drawings often didn't really fit with reality, or once I'd actually assembled the hardware, I noticed that there were things which were out of place or could be done better. So after that I went for a more sort of Heath Robinson, seat of the pants kind of approach, and designed things in a much more hobbyist, on-the-fly sort of way. Just taking measurements by thumb, only taking occasional measurements, and very rarely doing anything resembling a technical drawing. And that's suited me well, at least for the time being. Over the years, people have asked me for drawings and plans for the Rodney robot, and I've always said that it's really purely a one-off sort of research robot. I don't really have any detailed drawings or plans that could easily be reproduced. I did make a sort of inventory on my website, but it's not at the level of high detail. So you would have to ad-lib quite a bit to make something similar.
For folks listening in who may not be familiar with the hobbyist robotics community, it's probably relatively difficult to describe something like that succinctly, but can you give some general description to the community and how it may compare to the artificial life hobbyist community?
Right, well, I'm not massively familiar with the artificial life hobbyists community, so I don't have an awful lot to compare against. But certainly for my part, I was mostly assembling pre-built parts that I bought in. So things like the servo control, the cameras themselves, the communication between the PC and the robot. All these were things which I hadn't actually physically made myself from. I hadn't made the circuits or I hadn't built the electronics from scratch. I just assembled it. So I've always kind of tried to follow that sort of approach with building stuff. Now, I'm not sure whether that happens within the A-Life community in terms of building from pre-made parts.
No, that's not a... Yeah.
You could say that the same applies in robotics also in terms of the software, in that historically robotic software has tended to be written from scratch. It's only relatively recently, within the last few years, that there's been even attempts to standardize software and avoid having to rebuild fundamental components, such as asynchronous communication between different parts of the robot. So I probably haven't got a tremendous amount to say on that, just because my knowledge of the A-Life community isn't very great.
Okay, well, removing the contrast then, how would you describe the robotics hobbyist community?
It's certainly vibrant. There's a lot of passion around it. There are a number of stores, commercial enterprises selling hobbyist parts or even complete robots. And I've seen those only get larger over the last decade or more. A lot of stuff that hobbyists do with robots is not at the level of high intelligence, but often things like walking or avoiding obstacles. But over the years, I've seen there's an increasing convergence between what hobbyists do and what academics do in research. And especially in the last couple of years with a system called the Robot Operating System, originally made by a company called Willow Garage. You can see that robotics hobbyists and academics are really definitely converging on the same target.
So that's interesting. So it's through shared goals that they're converging?
It is, yes, I think so, yes.
Very interesting.
As I say, going back to some of the stuff with Rodney, the kinds of problems that you come up against when you build any sort of robot are pretty well known now, and they're often related to perception of the environment. It's only really quite recently that good solutions for that to overcome that sort of problem have emerged, and you can see that in recent times that's emerging partly from academia, but also with some help from hobbyists too.
So what came after Rodney?
After Rodney, I also made an anthropomorphic robot called Flint, and this was a kind of a chimp-like robot. I thought it would be quite fun to make something which was a bit more animatronic, just to experiment with that sort of thing. So I'd seen the movie AI, which I thought was quite terrible, but it did have this walking, talking teddy bear in it. I thought it might be interesting to do something which is kind of similar to that, or have a go at that. So I looked around for teddy bears of various sizes. The ones I saw anyway were pretty expensive. So I looked out for other possible alternatives and looked at various kinds of puppets. And eventually, on the web, came across a website which was selling chimp puppets, which looked quite realistic. I thought this was potentially quite a nice animatronic subject. Rather than going for a teddy bear, I looked around on the internet and found a website that was selling chimp models, or they're actually ventriloquist dummies, which were hollow inside. But they look quite realistic, so I thought this was quite a good potential subject for turning into a robot. So I actually bought one of those and took it apart, took out all the stuffing, and inserted various contraptions. I have actually got some images of the Flint robot without the external covering, and had to go at animating that. It was quite tricky, particularly to get the skeleton inside the head of the chimp dummy. That involved quite a bit of jiggery pokery to get things the right size and dimensions and so on. But I did manage to figure that out in the end. The Flint robot was operational for a while, maybe in 2003-04. I didn't do an awful lot with it actually, and even now it's kind of largely on the shelf, mostly unused. The distance between the eyes, the distance between the cameras I was using in the eyes, is pretty small. I think it's only about 3 centimeters, something in that order. So the amount of stereo that you can get from it is pretty minimal. And the resolution of cameras that I had at the time was also not very good. So I didn't have very good results on that. Although it was quite amusing to have this thing animated and move around and sort of shock people when it suddenly moved without warning, unexpectedly. So I had a brief sort of foray into animatronics, but didn't go very far down that line.
And what happened after Flint? What came then?
After Flint is the robot that I'm currently working on, which is called... Oh, actually, there was one before that. It's called Grok 1. That was based on something called the Quirk, which is a piece of electronics made by a company called Charmed Labs, which has a little computer on board, and it has a lot of other stuff which is related, makes it quite suitable for robotics. If you have a look on the Charmed Labs website, you can probably see it there. There's a number of CMU-related projects around that, mainly related to education, getting kids or students interested in robotics and having them be able to put together a robot quite quickly and easily. So around about 2006 or the beginning of 2007, I noticed all that was going on and thought I would have a go with that particular hardware and made a tele-robot out of it. In other words, just a robot with a camera on it which was connected to the internet, so you can drive it around from an internet-based interface with a pan and tilt, so you can move the camera around, and a couple of tracks on the bottom, like tank tracks. The tank tracks weren't very successful. In hindsight, I probably should have used wheels, just fairly large wheels. Tank tracks, as it turns out, don't really work very well on carpets, especially if they're longish carpets. They tend to get stuck. They're also very inefficient when you try to turn. You get a lot of slip and pose error that way. Energetically, probably not very efficient either. But that was a robot built in around 2006/7, and I always knew that would be a kind of intermediary robot, because just as with Rodney, I was mainly interested in this vision problem of the robot understanding its surroundings and the shape of its surroundings and what's in its surroundings. So the actual Quirk board didn't really have enough computational power to be able to tackle the sorts of problems I was really interested in. It was possible that I could transmit the images to a PC and then do it on a PC, but that maybe wasn't ideal from the way it was set up. So I always kind of knew, even while I was building that Grok 1 robot, that I would probably need another robot at some later stage, which was probably capable of carrying a PC or a laptop or something of that order, where I could sort of apply the full weight of Moore's law to the problem of vision and understanding the environment. by the time 2007 came along, I was living in Sheffield and earning a decent wage in a different industrial sector, but also related to computer vision. So at that time, I started building the Grok 2 robot, which is the robot that I've currently got and I'm currently working on. That's a much larger robot. It's based on a bought-in robotic base, which comes from a company based in America called Zagros Robotics. It's got a website. I think it's called zagrosrobotics.com. It's an AL101 base for anyone who's interested. It's pretty large. It's got easily enough capacity inside it to stick a PC motherboard or a laptop. Plenty of space for electronics, and if at some stage I want to put a large car battery or some other type of battery at the bottom of it, there's ample space for that kind of thing as well. And I also wanted something which was mobile, unlike the Rodney robot, which has no legs and can't move around under its own steam. I wanted something which could move around on wheels, and where the cameras were approximately the same height as a typical sort of adult human, so it could see the world from a sort of human perspective. Just to get some idea of what kind of things people can see, what kind of things people are interested in. Because if you've got a robot which is close to the floor, as many experimental robots are, the view from close to the floor is incredibly uninteresting. And, you can't see things like desk surfaces, or it's very difficult to see door handles. Anything which is really of very much interest to people. So I wanted something which was fairly large in that case. That's more or less what I've got. Actually, so I've got the AL101 base with what is actually a drain pipe stuck on top of it, which is acting as a kind of neck, on top of which there's a head with stereo cameras. And I've been experimenting with various types of vision on top of this robot, such as omnidirectional vision using a mirror or a pair of stereo cameras made from 4 webcams.
In terms of the logical progress from this, you throughout your development of robots, the software component has moved more into from roll your own into open source componentry. Can you talk a little bit about what's available now in terms of open source for robotics?
Right, there are an increasing number of pieces of software that are available for open source robotics. Probably the main one at the moment is called ROS, Robot Operating System. And unlike as the name suggests, it's not actually an operating system in itself. It's more like a set of commands, operating system commands. So it's primarily intended to run on Linux, although I think it does run on other platforms. And it basically replaces or has equivalent commands to the sorts of commands you would find in Unix. So things like make or clean, this sort of thing. We're actually building components of robotic software, and this sort of stuff is pretty useful because it takes a lot of the drudge work out of getting systems to communicate with each other, transmitting information from one place to another, such as images or encoder data, things like this. Previously, from about 2005 onwards, I had written my own system, which was doing something which was quite close to what ROS does. It was written in C#. It was called Robot Bridgeware. But by 2009, I'd noticed that the ROS system was doing some stuff which was sufficiently impressive and sufficiently similar to stuff that I was writing myself that I might as well just ditch what I was writing and adopt that because it had a larger community around it and was better debugged than what I was doing at the time. But apart from ROS, there are plenty of other things as well which are of interest. Systems like Oracos. There's a system called Mobile Robot Toolkit, I believe, which is mainly related to SLAM algorithms, I think, although other stuff as well. And there's Open SLAM, which is a list of open source algorithms for simultaneous localization and mapping, which is quite useful. Mostly developed under the guise of academic institutions of various kinds. It's definitely accessible to hobbyists as well. Also, another interesting development is a site called Raw Seeds, where people can upload datasets related to robotics. And what they've tried to do is develop some benchmark tests so that you can potentially test algorithms against each other in different environments and say this algorithm is so much better than that algorithm in a given environment. And that's I'm really impressed by that, and that's a really good direction to go in. That it turns robotics into much more of a science than it was previously, where you can really quantitatively make comparisons between systems, compare their performance in different conditions. So there's quite a bit of stuff out there. There's no doubt other stuff that I'm not mentioning. Certainly any trawl through SourceForge or other open source sites can bring up probably numerous open source projects related to robotics.
And I guess realigning to the topic of artificial life, your first, I'm trying to think when we first started corresponding, but your first main correspondence in the artificial life community, when did you start reaching out to the artificial life community?
I'd written one, or maybe a few artificial life-like programs in the early 1990s. But I was never really involved with the artificial life community as such. And been a listener to Biota. Mainly, I think I learned about Biota possibly through Steve Grand. Maybe he had a link to it on his website, something like that. But I've been a listener to podcasts about artificial life and that sort of thing for a while. I would describe myself as having a peripheral interest in artificial life rather than being an active practitioner. Unless you qualify the robotic stuff as being within artificial life, which it might be.
Possibly. In terms of your contributions, though, you've contributed a substantial amount recently to Noble Ape. Have you worked with any other artificial life projects?
I haven't, no. Noble Ape is the first open source artificial life project that I've been involved with, other than my own little projects from many, many years ago.
And I guess through Biota you found Noble Ape.
That's right, yes.
In terms of your experiences in robotics, aside from, I guess, the C programming language, what do you think you brought into the Noble Ape development?
Well, probably certainly more complexity surrounding social interactions. Things like having a social graph of sorts, just fleshing out some of the interactions between beings in the simulation. I thought it would be interesting to maybe look at the question of is it possible to develop an artificial society. In the early to mid 1990s, I'd read at least one book, maybe two, maybe got a few out from libraries, which included articles about the possibility of simulating societies, studying how societies develop, things like that. So I had a kind of peripheral, in the background interest in that sort of that sort of aspect of it. And it seems to be an interesting open question which nobody else is really addressing. How do societies originate in the beginning? How do they evolve? What sort of properties do they have? Can you move towards a scientific understanding of society? Can you have a scientific understanding of cultural evolution? And you can look at memetics and things like this. There's lots of interesting possible things that you could look at in relation to that. I should say as well that I'd always had a kind of interest in the possibility of developing a simulation of a natural system which was moderately realistic. As far as I know, this has never ever occurred, but it would be really nice if some individual or organisation tried to develop a simulation of an environmental niche, like say a pond or a puddle or something, a micro niche, something quite small, but then they tried to simulate the biological entities within that niche in as much realism as we know how to simulate with current knowledge, current biological knowledge. And that would be a really interesting thing, and you'd be able to look at how those ecosystems work and where the missing knowledge is. That's probably the most interesting aspect. What is it that we don't understand about ecosystems and the dynamics of ecosystems? And as far as I know, nobody's really done that, but I could be wrong because I'm not an expert on the A-Life community.
Returning to your idea of creating the simulated society, I guess this is almost returning to your hobbyist academic distinction as well. I mean, one of the problems that I find developing Noble Ape, and this really came through the Stanford Research Institute talk that I gave in July this year, is that you put all this energy into this thing, this simulation, you construct various things,
yeah.
You create it, and then you have to work out a way that you can get the academics that would be interested in these areas involved with the simulation. Now, you describe with the robotics community that the hobbyists had been very successful in terms of integrating with the academics based on shared goals. In terms of the perceived shared goals here, how do you think one should reach out to the academics and explain that you have this environment? Obviously, clearly there are shared goals there, but there is an additional component that seems to be missing in the artificial life community. What do you think we could learn from the robotics community in this light?
Well, it depends what those shared goals are. Probably the best way to proceed is to maybe try and elucidate what those goals are. Certainly within the robotics community, there are anybody who gets involved with robotics usually comes up against some pretty hard problems pretty quickly. And those are shared across hobbyists and the academic community. To what extent that happens with A-Life, I'm not sure.
I guess what you're describing with the academic and hobbyist communities with robotics is that they're both shared technical communities. And the difficulty with regards to A-Life is that it's a technical community that then needs to liaise with what you would hope would be a technical community, but actually turns out to be, for example, biologists, or within the social sciences, a wide variety of other academics. There are elements of these disciplines that are moving into computational methods. I'm thinking of computational linguistics in particular. Right. But in general, there is not necessarily a resistance, but certainly a very striking perception that anything that is simulated is strictly artificial and very much a kind of reduced subset. And I guess the problems that we've found in Noble Ape and the stuff we've been talking about recently in terms of the need to carry statistics and have interactive graphing and show representations and actually give this complexity a very visual and understandable, or at least graphable form, is part of that problem, which I think probably makes the stuff that I'm describing in terms of artificial life reaching out to the biological or the social sciences quite distinct from the robotics community, where you say it is very, not to make a pun, but very nuts and bolts related problems versus something which is distinctly more abstract. I guess
Yes.
the shared. This is the interesting thing with regards to the posters, because this is something that I've thought about, and I'll be going to what is a theoretical, philosophical, biological conference in Salt Lake City next year. But the potential actually to create posters and deliver them and write papers and do all the things that I think we're probably already doing in the artificial life community in terms of linking with perhaps semi or non-sympathetic academics is being done. But what you describe in robotics seems to be very much because of shared goals. These things can be meted out a lot faster. But I guess it's a long-term project, and certainly these things will take decades, not weeks, unfortunately.
Yeah, well, certainly in the case of robotics, I think the common goal is the real world. The real world is the enemy that you're up against, that you're trying to understand, and that you're trying to react to. In the artificial life context, it might be better to, if you can produce a lot of statistical output, graphs and so on. It might be the case that academics can then recognise from these graphs that the problems that the hobbyists are dealing with are kind of similar to things that they're also familiar with within their realm of expertise. That might be a good way to define some common ground if you can make it more graphical.
Yeah, it would be a problem. I was thinking, in parallel to this, there's a project I'm working on called the Biota transcripts, which takes all the audio from previous Biota lives and creates basically something that academics that want searchable or electronic forms can then use to reference. And what you're describing here is exactly the same issue in terms of the fact that what we produce as simulators may be something which is abstract and intricate from our own perspective, but it's translating it to very simple things, as you say, like graphs and things translating it really to the language of the academics that may actually use this. And I think, that's a very good point. And the interesting thing through your interaction with Noble Ape, I'd encourage all artificial life developers to bring in as many people as possible to their projects, but also folks such as yourself who are, if not experts through profession, experts through experience, can yield, from different areas, can provide amazing insights. And certainly that's been my experience working with you with Noble Ape, and certainly, much thanks to you, Bob, because I was thinking that the talks that I gave in July would have been relatively boring if it weren't for your particular input. And I think the stuff that you've added to Noble Ape, I'm still decompressing in terms of the potential impact and potential direction. But it really does add an additional richness. In terms of the other artificial life projects, you've listened to previous Biota podcasts. In terms of other artificial life projects, what other projects that you've heard about interest you?
Artificial life projects?
Yes.
Well, I've not heard of all that many, to be honest. I've heard of Steve Grand's stuff with creatures. I've read about simulations such as Polyworld and some of the old stuff like Core Wars. But apart from that, I don't think I know really. I don't really have my finger on the pulse of artificial life simulations, so I'm probably way out of date and don't really know very much about them.
So you mentioned the idea of simulating even a confined environment like a pond or a puddle with the maximum amount of possible contemporary biological knowledge in a computer simulation.
Yeah.
Is this the kind of direction that you'd like to see the artificial life community going? Basically, I don't know, representing our current knowledge base and then just pushing it forward through additional simulation time. Is this the image that you see?
Possibly, that might be an interesting avenue to go down. And if you do go down that route, then you may well be able to attract attention from other academic fields, biology, ethology, so on. Because if you can demonstrate a simulation which looks pretty credible and is using the most advanced knowledge that's known at the time about those particular organisms, then you can maybe define some common ground with other biologists. So, for example, if the simulation doesn't match what you know from biology, you can consider why it doesn't match it and what's wrong, and try and figure that out.
Very good, very good. Well, Bob, it's been an absolute pleasure talking with you today on Biota Live. I know that you've been an avid listener for a number of years, and I'd like to also invite on other folks like Bob who may not necessarily be artificial life practitioners, but certainly see Venns in their own work or their own interests onto the Biota podcast, because it really is wonderful to have people such as yourself on the podcast, Bob.
Yeah, okay. No problem.
Well, thank you, Bob, for the chance to chat today. It's been a pleasure. Talk to you
Cheers,
soon.
Tom.
Take care.